Good morning, everyone. I hope you are having a pleasant morning. So, this is our second lecture of Basics of Organic Chemistry and Hybridization. I hope you have done your yesterday's question that I gave you in the end of the lecture. Let's start our today's lecture in continuation with yesterday's work. So, I gave you yesterday some questions related to degree of unsaturation. Calculate the degree of unsaturation for the following molecules. In yesterday's class, I gave you from this list second, third, fourth, and fifth. Okay, I added one more here. So first, let me remind you what was the formula for degree of unsaturation. Okay, degree of unsaturation was, the formula was DOU is equals to C plus 1 minus H plus X minus N upon 2. This was the formula that we discussed yesterday related to degree of unsaturation, where C was number of carbon atoms, H was number of hydrogen, X was number of halogen atoms, and N was number of nitrogen atoms. We said there is no contribution or no effect of any bivalent atom like oxygen and sulfur. Okay, so using this, we can directly go C6H6. It has 6 carbons, it has 6 hydrogens, 0 halogens, 0 nitrogen upon 2. Okay, so 7 minus 3, 4. And yes, if you remember, this is benzene. It has degree of unsaturation 4. Coming to this second example, let me tell you what the answer for this will be. So carbon is 3. Hydrogen is 6. There is no halogen, no nitrogen. Oxygen is to be neglected. Okay, so it is coming 4 minus 3, that is 1. So basically answer for 2 is 1. If you see, it is some carbonyl possibility or any other molecule also, like unsaturated alcohol, ether, but it has 1 pi bond. Okay, coming to next, here we have chlorine also. So 3 plus 1 minus 5. 5 is the number of hydrogen. Plus halogen. We have 1 halogen, 0 nitrogen. Okay, so 6 by 2, 3. 4 minus 3, 1. Clear? Moving to next molecule, C9H8. 9 plus 1, 10. Minus 8 plus 0 minus 0 upon 2. Okay, so 9 plus 1 is 10. 8 by 2 is 4. So 10 minus 4, it is having degree of unsaturation 6, which is quite high. So what could be such molecule? You know such molecule. Let me draw here in front of the answer. A possibility of this structure could be something like exemplifying a cinnamic acid. It could be a cinnamic acid. Okay, moving to next, one example with nitrogen also. So it is 6 plus 1 minus 5 plus 0. There is no halogen. minus 1 upon 2. Okay, so 5 minus 1 is 4. 4 by 2 makes it 2. Right? 7 minus 2 makes it 5. Is that okay? 7 minus 2 makes it 5. So what could be the possible structure for this molecule? It could be something like this. These are just examples. These are not like these are the only cases. Just an example. Okay, this could be benzene. This could be benzene and so on. इसको भी हम बनाना चाहें some example तो yes we have CH2 double bond CH single bond CH2Cl. So there are so many examples possible. Okay, so this is just a revision of yesterday's work. One thing I want to add one more. If structure is given, then how will you do? So let me add one more example to this. If structure of the molecule is given, say for example, if we are given a molecule like this, okay, nothing else is given. We are just asked comment or calculate the value of degree of unsaturation for this given structure. तो कैसे करते? For such cases, first, a best method I would say is write hydrogens wherever required. I think this is 3 valency, so 1 hydrogen required. This one, this also will need 1, 1 and 1. Correct? Then you write the formula like our regular pattern. So it is coming C6 H6. Okay, there are 6 carbons and 6 hydrogens. Now 6 carbon and 6 hydrogen case we just solved in the first one. So once you get the proper formula, then you can directly use once you get the proper molecular formula, then you can use this mathematical expression for degree of unsaturation and calculate. It is a very safe method that way. Some people want to attempt it by counting the number of rings and all. That sometimes could be risky. It depends on your experience. It depends on your day. Sometimes even a very experienced person can make error in that. Okay, so I would always suggest find the molecular formula and then calculate. It is much safer. Okay, so now let us move to next stage. That was the basics. Now let us come to some important terms and classification of organic compounds. Now, classification of organic compounds can be done on several methods like functional group, the structures, the number of atoms, and so on. Okay, so this classification I'm using here is based on structures. What we are discussing now is based on structure. The functional group and all will surely come, but it will be discussed in IUPAC nomenclature portion after say half an hour. Okay, so based on structure, organic compounds are first primarily divided into two, that is, whether they are cyclic or they are acyclic. Cyclic, that is, they have a closed loop or a ring. Acyclic, that is, they are open chain. They are also called aliphatic, but I will not stick that aliphatic is here itself. Let me proceed. I'll use this term again. Now, cyclic are further classified into homocyclic and heterocyclic. Okay, cyclic and acyclic is okay, but cyclic are further classified as homo and heterocyclic. So, homocyclic or carbocyclic are those in which the complete ring is only of carbon. Okay, it should be completely of carbon, otherwise, it should not be of any other atoms involved. Okay, Heterocyclic is definitely having something which is not having carbon. Heterocyclic, see in the loop, I have exemplified with oxygen, with furan, with tetrahydrofuran. You can have pyrrole here. You can have pyridine here. Okay. Then we move to homocyclic into early cyclic and aromatic. Okay. So early cyclic are, see, I told you I will use the word aliphatic again. These are called aliphatic cyclic and aromatic. So early cyclic are like cyclohexane, cyclobutane, decalene, cyclopropane, etc. Aromatic is a particular condition that we'll discuss later. Oh, not here. These will go in heterocyclic. So benzenites like benzene, naphthalene, phenol. See, phenol, but oxygen is not part of the loop. We said it is homocyclic. The loop should be only of carbon. So what is other example of non-benzenite but homocyclic? We have one example. If you all remember, I can draw. That is azulene. Azulene is an example of homocyclic and non-benzenite aromatic systems. Okay? So this is a general classification of organic compounds based on the structure. The terms that we'll use frequently in our discussions are here. First, homologous series and homologues. So what is homologous series? Homologous series is a group or set of compounds. A group or set of compounds primarily and compulsorily should have same functional group. That is a very important point. Should have same functional group throughout. If you're talking about alcohols, they should all be alcohols. If you're talking about amines, they should be amines, alkane or alkene or alkyne. Then their respective functional group should be maintained throughout the series or the given set of compounds. So they should have same functional group. The complete set, whatever is asked, should have same functional group. As they have same functional group, they also have same empirical formula. But I would not say this is my primary condition. Same empirical formula could be of isomers also. But that does not make them homologues. So first thing, same functional group. Then I'll say, okay, they also have a same empirical formula. Then consecutive members. Consecutive members should differ by 14 units of molecular weight, or I can say should differ by CH2 unit. They should either differ by, I can say, CH2 unit, or should differ by 14 units in terms of molecular weight. Either. But after considering that consecutive members word, some of you make a conclusion which a teacher might have never said, that only those which have a difference of CH2 or 14 units will be called homologues. No. In a question you can be asked anyone from that series, need not to be exact consecutive members. So then also you will take an option of homologue. So what am I said? I might have confused some of you. So let me clarify. Let me exemplify what have I said. For example, talking about alkanes. Okay. Alkanes general formula CnH2n plus 2. So in the series, in the continuation, I have methane. I will have ethane. And similarly, if I go like this, C10H2N plus 2 to C10H22. Let me say decane. If I go like this, methane, ethane, propane, butane, pentane, and dash 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 to decane. Okay, so all these members, any member of this series is called homologue, and a continuous series is called the homologous series. So, in a question, you may be asked whether methane and decane are homologues or not. Are homologues or not. Okay, so they are homologues because they are from this series. That is, they have the same functional group, same empirical formula. And if I go by consecutive member series, ultimately I will land from methane to decane. So any member from this series, any member of the homologous series will be called homologues of each other. For the word homologue, you need to have at least two molecules in the question because it is a relationship, it is a condition between two different molecules. So whenever they ask which are the homologues, you need to have two molecules. You check these conditions. If those two molecules lie anywhere in the series, then also you have to take the word, yes, they are homologues. Okay. Homologous, this was the alkane series. I can have similarly alcohol series. Similarly, you can have alcohol series and so on. Okay, now if you go by the same empirical formula, you can have alcohol and ether, a same formula, but they'll not be called homologues because the primary condition for a pair of molecules to be homologues is the same functional group. Okay, so alcohol, so first you will check in a given set of molecules whether the functional group given is same or not. For example, if you check these two, this is C2H6O. Okay, this is C36H8O. So, what is the difference between these two? 2 to 3, C, 6 to 8, H2. Okay, they have a same fixed required difference of 14 units and CH2U. They have the same empirical formula, but still you will not call them homologues because they have different functional groups. So the most important condition you have to check is functional group. So these are not homologues. Okay, now I'm repeatedly using the word, continuously using the word functional group, functional group. So what is this word functional group is? Right, what is this functional group? Everything is depending on functional group. Well, functional group is, I can say it could be an atom or it could be group of atoms. An atom or group of atoms. Take in the molecule. It should be the part of the molecule which is in question, which you are studying in the molecule, which decides or is responsible, for maximum number of chemical and physical properties of that molecule. Okay, which decides maximum number of physical and chemical properties of that molecule. For example, if I talk about CH3CH2OH, it is derived from alkane CH3CH2H. So H, when replaced by this OH turns the molecule upside down. That is, entire behavior, entire chemical as well as physical nature of this molecule has changed as compared to its parent molecule. Okay, so what all is changed? As you know, ethanol has very high boiling point as compared to ethane. It has high water solubility due to H bonding, right? It becomes acidic, it can behave amphoteric, it can behave basic, and so on, so many properties. So what we see that presence of this particular OH group brings very important changes in the physical and chemical behavior of this molecule. So this OH will be called functional group. Okay, there could be so many different types of functional groups. If I could just give you an example of few, let me write examples of functional group. It could be, of course, we have said alcohol, it could be halogens. Okay, even alkene and alkyne are also taken as part of functional groups. Aldehyde and ketone, carboxylic acid and derivatives, sulfonic acid, okay, amines, ether, NH2, NO2, and so on. So there are so many different types of functional groups present in the nature because organic compounds are so many in nature. Okay, so I hope now the entire idea of homologous series and functional group is clear to you. Okay, functional group is any atom or a group of atom in the molecule which controls or decides maximum number of its chemical and physical properties. Okay, and for a homologous series, the primary check is whether the given set of compound have same functional group. Second check is whether they have the same empirical formula. Then they are definitely homologues of each other. Okay, and the continuous series formed by maintaining the above 2 points and having a fixed difference of 14 RCH2 unit is named as homologous series. Okay, so moving to next, we would surely need this term in future, that what is the degree of carbon, what is the degree of hydrogen. So now as we have moved to the word functional group and homologous series, this is a few seconds work to understand. Degree of carbon. Based on how many carbons a particular carbon is further connected to, it is classified as first 1 degree or primary, 1 degree of primary carbon, 2 degree or secondary carbon, 3 degree or tertiary carbon, and 4 degree or quaternary carbon. So we have 4 types of carbons based on degree of carbon. So if a carbon in a molecule is further connected to only one more carbon, it will be called primary or 1 degree. Further connected to 2 more carbon, secondary or 2 degree. Similarly, 3 carbon, 3 degree and 4 to 4 degree. Let me give you a structure and let's see that उसमें हम maximum points हमारे. See this molecule. Okay, so let me mark my primary, secondary and tertiary. 1 degree, 1 degree, 1 degree. These are my 1 degree carbons, including this one. Okay, moving to secondary. This is my 2 degree, 2 degree. So I have 3 2 degree carbons. Okay, in my given example. Moving to next, that can it have a 4 degree? Yes, see this carbon is connected to 4 different, this is 4 degree. Similarly, this is connected to So this is 4 degree. I hope you have got my point. And again, as a work to you, please count number of primary, secondary, and tertiary hydrocarbons in this molecule. Okay, just as a practice, in your notebooks, you note this point, you note the structure, and count the number of primary, secondary, tertiary, and quaternary carbons in this molecule. Okay, moving to next, what is the degree of hydrogen? Okay, degree of hydrogen is based on the carbon with which hydrogen is connected. See, if it is hydrogen is connected to primary carbon, then it is called primary hydrogen. If it is connected to secondary or 2 degree carbon, then it is called secondary hydrogen. If it is connected to 3 degree or tertiary, then it is called tertiary carbon, then it is called tertiary hydrogen. And similarly, could it be 4 degree or quaternary? No, because if a carbon is 4 degree or quaternary, there is no possibility of hydrogen attached to it further. So there is no case of 4 degree or quaternary hydrogen. Okay, you can repeat the whole exercise of counting the hydrogens in the above example. So I'll just give you answer. In this example number 1, number of 1 degree hydrogens or primary hydrogens will be, as we have 1, 2, 3, 4, 5, 6, 6 1 degree carbons. So I think I'll have 18 primary hydrogens. Okay, now I have 1, 2, 3. The 2 degree hydrogens will be 6. There is no 3 degree hydrogen in the given example number 1 because there is no 3 degree carbon. First, there has to be that type of carbon. Then you will call it that hydrogen attached to that carbon is so and so degrees. Okay, moving next. Let us now move to nomenclature of organic compounds. Well, nomenclature of organic compound is very important. Almost every alternate year in mains in advance, you can see 1 or 2 questions coming from this. So it is certainly a very important topic. You need to work on that. And most of all, if you make any error in concluding the structure based on the IUPAC name or the common name, you ruin the complete question and lose marks. So nomenclature of organic compound should be done very carefully and sincerely. Okay, so nomenclature of organic compound is first divided into common names, trivial names, or the IUPAC. Let's spend few minutes hardly on common names or trivial names. Now, common names or trivial names were based on the origin of that particular compound or the language wherever it is used or related to from wherever compound, wherever structure, molecule, organism, plant, fruit it is related to. There is no fixed rule, fixed logic that particular thing will be given this type of trivial names. Yes, we do have to remember certain common names. Why? Because they are so much in practice that you cannot work without them. Let me exemplify and just few names which are so important as per their common names we can't help. First example, let me say acetic acid. Now, when I write acetic acid, I think all of you must be remembering its structure immediately. Okay, it can be named ethanoic, but it is so much in practice with the word acetic acid. You need to remember the word acetic acid. Acetic acid is the word which is derived from Latin language, from the word acetum. And what was acetum in Latin? It was a chief component of vinegar. The Latin में vinegar is called acetum. So from that vinegar term, they have given the term acetic acid. Okay, let's move to similar one. I have written this structure. I think all of you got the common name, formic acid. IUPAC, yes, very simple methanoic acid, but again, it is a matter of practice. You can't help. It is derived from the Greek word. This one is derived from Greek language. In Greek language, the ants are called formicus. Okay, what was formicus? Ants. What was acidum? Vinegar. Ants. So it was derived from formicus. So it was named formic acid. And similarly, and so on. There is no end to this. You have to go through them. And my suggestion is when you revise your complete chemistry, organic chemistry, please make a small, very small, I want to say those very short notes booklets that you get in the market, na? Which are hardly of 20 rupees, 25 rupees, or I don't know, maybe even 10 rupees. Please take that one booklet, very small copy, okay, and in that start making the list of common names when you start revising. Please maintain that book throughout your completion of syllabus, or I would say till you appear in your IIT. Keep referring that. I won't say that just you sit down and cram all the common names in a one go, but you need to keep that booklet, maintain that booklet. You will have almost 150 to 180 common names which may appear in an IIT paper. Okay, so maintain that booklet, keep writing those names there, and use it like a dictionary. Use it like a dictionary. Anytime you refer from that, what is the name, and use it, that would be of great help to you. Okay, so now coming to IUPAC nomenclature of organic compounds. I know all of you know the full name of IUPAC. I didn't say I believe, I know. It is International Union of Pure and Applied Chemistry. IUPAC is International Union of Pure and Applied Chemistry. It is, I would say, a group of scientists which are given the authority, power to make judgments, to make rules regarding organic chemistry, which will be followed throughout the world by different organic chemists. Okay, we needed IUPAC names desperately because there are so many molecules. If I go by trivial names, it won't be of much help because that would depend on language to language, region to region. Something that in English is, say, called lemon. In Hindi, it is called nimbu. In other languages, it could be called anything else. So if I depend from language to language, region to region, it will become very difficult to communicate chemical reactions around the world. So we definitely needed our IUPAC nomenclature desperately, and this IUPAC rules that were given by these group of scientists are accepted throughout. There is an entire booklet of IUPAC nomenclature, but we have to limit ourselves with respect to our JE syllabus. Don't go beyond that because there is no end. As you know, organic chemistry has no end. So try to limit your work, try to limit your study as per the defined syllabus of IIT JE and mains. Okay, don't be worried about if there are four functional groups, what will happen, if this type of cycle or this type of aromatic system, what should be the name. Please limit yourself to what is being asked. In the end of IUPAC nomenclature, I'll give you the source of assignment which you could use as a defined source to work, to practice on IUPAC nomenclature. Till then, you write the rules and study the rules that I'm discussing with you. So IUPAC name is basically having broadly four parts. Okay, the prefix, the root word, primary suffix, and the secondary suffix. Now, what is this whole thing? This prefix could be something like, okay, it could be something like alkyl substituents, alkyl substituents. It could be like less preferred functional groups. If it is a multifunctional group molecule, then you can put the less preferred as prefix. Okay. It could be the positions जो कई बार हमें देनी होती हैं. ठीक. It could be, just in case, some di, tri, tetra, etc. terms. We could have these as a prefix. Now let us see what all is this. But the most common are these two. That is the alkyl substituent and the less preferred functional groups. These will be placed as prefix in an overall IUPAC name. Root word. Root word indicates number of carbon in longest parent chain. PC, I'm using the word for parent chain. So number of carbon in the longest parent chain. Based on those carbon count, you will decide what root word you are going to use. Right? For example, you must be aware of the words like meth, eth, prop, bute, pent, hex, hept, etc. Okay, so these are the root words. Primary suffix. Primary suffix indicates type of bonding in carbon of, between carbons of parent chain. If all the carbons are single bonded, then this primary suffix is "-ane". If any one is double bonded, "-ene". If any one becomes a triple bonded, then you use the primary suffix "-ine". Okay? Secondary suffix, that is on the basis of the functional group present in the molecule. So secondary suffix, once you see, it indicates the main, or I would say the word preferred functional group in the molecule. Okay, it indicates the main or the preferred functional group in the molecule. I hope a basic outline of IUPAC is created in your mind, that a particular IUPAC will have 4 parts: prefix, root word, primary suffix, and then the secondary suffix. So let's start with the rules that we need to follow while assigning the IUPAC name. Okay, rules for writing IUPAC name. First, you have to count the longest carbon chain. Okay, longest carbon chain rule. For that, you have to count the continuous carbon chain in all possible directions in the molecule. There is no rule like the horizontal or a vertical or a zigzag, any possible direction, but it has to be continuous carbon chain without any heteroatom breaking the continuity. Okay, so select that longest continuous carbon chain in the molecule as the parent chain, and rest all other parts which are not included in the longest chain will be later taken as substituents or the branched chains. So for example, in this, what are my possibilities? If I take this as a continuation, I will have 5 carbon. Okay, and if I take this as a continuation, I will have 4 carbons. Similarly, other side is also giving me 4 carbons. So definitely it is going to be a 5 carbon. This is going to be a derivative of pentane. I'm writing it here, leaving the space, because when I'll complete, I'll put the complete name also. Or you can put your complete name whenever you revise it. Okay, so what we were doing, we were counting the carbon chain in all possible directions and then deciding which side to be used. Okay, So that is what we are doing. Now coming to this molecule. Okay, coming to this molecule, if we see this molecule, we have so many possibilities. Like, what do I want to say with so many possibilities? Let me put the numbering all around. Okay, if I put the numbering all around, my position 1, 2, 3, 4, 5, 6. That is my one choice. Okay. Other possibility could be, let us change the color, is 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I think there are two possibilities. Either I have to go for hexane or I have to go for octane. And certainly this is going to be a derivative of octane. Okay. The blue one will be taken as a parent chain. This is your first step. Count the carbons in the longest parent chain. Corresponding to that, you assign the root word, pent, oct. Check the carbon-carbon linkages, as all in my two examples are single bonds. So I was directly using the primary suffix "-ane". In case if you have a double or a triple bond, use "-ine" or "-ine", whichever suits for the given molecule. Okay. One more thing, if the molecule is cyclic, then the root word is to be further prefixed with the word cyclo. If it is cyclic, then the root word is to be prefixed with cyclic. Okay? For example, this has 1, 2, 3, 4, 5. So my root word is cyclopent. As all are single bonds, I will put the word "-ane". This is also going to be cyclopentane, but some other changes, some other parts to be added that I'll add after a few seconds. Okay. Once you decide the root word and the primary suffix, now you see what all are left. See what is there. The other parts which are not included in the longest chain are to be taken as substituents. So here we took this. So my substituent here is methyl. Methyl. Okay. Here we took octane, that the blue one. Okay, so I have 4 methyls. I don't want to mean the position by writing this 4, so I should better write in word. Okay, otherwise it might confuse others. So I would write in words, I have 4 methyl substituents. Okay. Similarly, here I have 3 methyl substituents. So whatever is left, you just put a note that, okay, what are left and what are those substituents. The numbering I will discuss in the next point. So you have got what all the substituents are. Once you decide that these are the substituent, you need to number the carbon atoms. You need to number the parent chain, numbering in a normal numerical way, 1, 2, 3, etc. Starting from, this is a very important point now, starting from the end, which gives smaller number to the carbon atoms carrying the first substituent. Okay, so what does that mean? Basically, we are coming to lowest set rule. I want to be very loud, very clear and emphatic that there is nothing called lowest sum rule. It has been discarded long time back. So if you have ever seen, or if you have any image of there is something called lowest sum rule, please just remove it totally from your brains. Okay, there is nothing called lowest sum rule. ऐसा कुछ नहीं है. Please remove that totally. What should I do to make this point as much clear as possible? No, 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 no. Okay, you don't have anything like lowest sum rule. You strictly have to follow lowest set rule, which is given in NCERT. Lowest set rule, that is lowest set of locanes. Now, what is lowest set of locanes? Okay, for assigning the numbering, you number the parent chain from either ends, left to right, right to left, up to down, down to up. You number from either sides. So for here, if I number it 1, 2, 3, 4, 5. I said number it other way also. So okay, we'll do 1, 2, 3, 4, 5. So when I go blue wala marking, I am having the position set of substituent as 3, 4. Okay, whatever set you get, you write it in an increasing order in a bracket. And in a green mode, when I go this way, in a green mode, I got a substituent set as 2, 3. So you write the substituent in a small circular bracket with a comma. Now you start comparing those two sets. So 2 is to be compared with 3. Okay, so you wherever you come across as a first point of difference, in my case, in given example, first number itself is that point of difference. Okay, but in case if it is not, you move to next number, compare the third or the fourth or the fifth, whatever it may be, you just continuously move on, compare the set, and whichever point, first point of difference you acknowledge, at that point of difference, which set is having lower number is the correct set, reject the other. Is that okay? I hope I have made my point very clear. Okay, you have to number the parent chain from all possible directions, left, right, left, whatever you have. Then you have to write the set in increasing order of numerals. Compare the set. Compare the set. The set with a lower value of numeral at first point of difference is the answer, is the correct set, and reject the other. So after assigning the position, you just have to place those groups in alphabetical order with position and construct the IUPAC name. So using this, let me write the name. We prefer 2, 3. Now 2, 3. As the groups are identical, I will use the word di. Numerals and alphabets are separated by hyphens. So it is dimethyl pentane. Okay, repeating the same practice here. Repeating the same practice, what are my possible sets? Let me first get that. 1, 2, 3, 4, 5. So if I go this way with a green, I am having 2, 4, 4. Why 2 4s? Because I have 2 methyls over there. Okay. Moving to blue, I have 1, 2, 3, 4, 5. So blue is giving me 2, 2, 4. Now here I have an example. My first numerals are same. So I'll go to next. So blue is giving you a set of 2, 2, 4. This is giving you of 2, 4, 4. So the selected or the preferred is 2, 2, 4. And thus the IUPAC name for this molecule is going to be 2, 2, 4. The rest name is continuation until unless you get another numeral. Trimethyl pentane. Okay, it is 2,2,4 trimethyl pentane. Let us repeat our practice in our all leftover molecules. Let us complete them also. So let me complete this. It is 1, 2, 3, 1, 2, 3. So this will be named as 3-methyl. I need to use eraser because the P is written capital. It should not be capital. It is 3-methyl pentane. Okay, numbering this. I have decided 8. I can see I have to move from this direction. Okay, numbering is to be done like this. Set appears to be better there. So 1, 2. So ये position 2, 3, 4, 5. ये position 5. So I think it is going to be 2, comma 2, comma 5, comma 5. Tetra. Let me write it completely. Tetra methyl octane. Okay, it is 2255 tetramethyl octane. Is it okay? Moving to next. This was our next. So if you number it like 1, 2, 3, 4, in cyclic there are so many possibilities. So if I go like 1, 2, 3, 4 or 1, 2, 3, 4, I think either side I am having the same number. So it doesn't matter. This is going to be 1, 2, 4. Trimethyl, again this C has to be made small. Trimethyl cyclopentane. Is it okay? Moving further. Fourth. Now see, if I go by say 1, 2, 3, 4, then my set is 1, 4, 4. First is set, not alphabetizing. If I go by another that is 1, 2, 3, 4, then my set is, this is, I went this way and now I am coming this way. Then my set is 1, 1, 4. This will be the preferred one. Yes, while writing, I will maintain the alphabetical order. So I'll write it. This is very important example. 4-ethyl. Now see, again I am moving to numerals. So 4-ethyl 1, 1 dimethyl cyclohexane. Okay, please mark this as a very important example. Practice it. It is from NCERT. It is very important. It has a lot of learning. So presence of more than one same substituent is there, then we use the word di, tri, tetra. We have already used it a little in advance to indicate 2, 3, 4, etc. same substituents. That is okay. Select the carbon chain with maximum number of branches. That is, if you come across a carbon chain with same count of parent, then you select the one which is having more number of branches. I'll exemplify later. But very important point. Okay, di, tri, etc. are not involved in alphabetizing. What do I mean by that? Okay, what do I mean by that? Let me tell you. For example, if I have dimethyl and I have ethyl. So for alphabetizing, I will use here E and here M. Because di is not part of the original name. It is that you are avoiding to write 2 times methyl. You are using a word di. It is fundamentally methyl only. Okay, so for alphabetizing, so when you will write it, you will write ethyl first and followed by dimethyl. Okay, so this is what I mean, that these letters are not the part of alphabetizing. Okay, I said I'll exemplify the other point. If there are 2 parent chain with same length, then select the one with maximum number of branches. So here I will just put which branch to select and we'll leave that on to you. I'll leave that on to you so that you can practice it further. Correct? So let me see. In this particular example, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The 2 possibilities of parent chain could be this or it could be this. Okay, which is selected, which is preferred. So if I select blue, the number of branches I will get is 1, 2, 3. 3 branches. If I select red, I'll get 1, 2, 3, 4. 4 branches. Okay, so red is the one which will be selected. That is what it means, that if you come across in two directions, two possibilities of the parent chain with the same carbon count, you select the one which has more number of branches. If, just in case, if you come across a question that if the number of branches are also same, okay, if the number of branches are also same, then you select the one which has less branched. Those branches should be less branched, less complicated. That is your second choice. Similarly here, if I select this horizontal pentane, I will have only one substrate. But if I select this as a pentane, same 5 count, but I'll have 1, 2, 3 substrate. So this is your parent chain. Okay, this is what we mean when you come across two equal size parent chain. Naming different substances. If two or more substances are present on the parent chain, they are named in the alphabetical order along with the appropriate positions. Positions we have discussed the locant rule. Alphabetical order I have discussed slightly. Like E will come further, E will come ahead of methyl, butyl will be written before ethyl, and so on. The dictionary order. You just have to follow the dictionary order and nothing else. Okay. Moving to next, naming different substrate at equivalent positions. If two different substances are present at equivalent position from the two ends of the branch, the numbering of the chain is done in such a way that the substrate which comes first in alphabetical order gets the lower number. Okay, so what does it mean? What does it mean? I'll exemplify it with this. I have already used. I'll exemplify if there are two possibilities. So let me add one more example here. Say this. Okay, now I have same set. You go up clockwise direction, you will have 1, 4. You go anti-clockwise direction, this way or that way, you will have a same set of 1, 4. Equivalent positions. Either side you are having an equivalent set of positions. Then you will select the one जिसमें जो alphabetical positioning is preferred will get the lower number. So this will be named now as 1-ethyl, 4-methyl cyclohexane. But please mind it that this alphabetizing use, this alphabetical order use for deciding the locant is only when you get identical set of locants. Like this, it will not be 1. Here ethyl is 4. We have just done it. Here ethyl is 4 only. See this one, the example I said. Okay, here ethyl is 4. 4 ethyl. But if you are having an identical set, only then you will use that particular point. If it is not an identical set, do not ever go by alphabetical order. It will be absolutely wrong. So it will continue to be 1, 2, 3, 4. That is only when it is part of identical set. This is a very important note. We are referring to NCERT here. Okay, what is the note? When you are constructing the IUPAC name, then in the alphabetical order, the word iso, neo, and cyclo, if these are the prefixes of your substituent, then they are included. They are included in your alphabetical order. Okay, but if it is these are the words sec and tert, then they are not, S and T are not included in your alphabetical order. Okay, that depends. Now, as we have to practice further how to name alkyl groups. Okay, how to name alkyl groups. So, we will discuss that naming of the alkyl groups tomorrow. We'll discuss naming of alkyl groups tomorrow. Please read your class notes. Okay. For IUPAC nomenclature, practice those molecules which are as per IIT syllabus. Here we will start our class tomorrow from here. Examples of alkyl groups. How to name alkyl groups. Okay. We'll start our work tomorrow from here. The best source for question practicing for IUPAC nomenclature with respect to our IIT JEE and mains exam is definitely and only NCERT. So you'll say there are only 10-15 questions in NCERT. How will I practice? No, my suggestion is tomorrow I'll complete IUPAC nomenclature. Then you go through 11th, that is part 1 of your organic NCERT, and part 2 of your organic NCERT, 12th. In each organic chapter, whenever they talk about functional group, they have respective nomenclature topic added and the examples. Okay, so both in text as well as the end chapter, you practice those examples. They are more than 150 or so. Plus, they are most authentic. That is what will be most reliable answers for IUPAC nomenclature. Okay, so wait till tomorrow. Today, you revise your respective class notes with the help of this lecture. Tomorrow, we'll try to conclude IUPAC nomenclature. Then you go through both year 11th and 12th NCERTs with their respective functional groups and practice those questions. That is the best source. Okay, so here we end our lecture today. Tomorrow again, we'll continue at the same time, 10 a.m. Till then, keep studying, keep working hard. Thank you, everyone. See you tomorrow.